This is video 22 in the lectures on the design of reinforced concrete beams. We will now have an example of how to calculate the maximum bending capacity of a section based on the stresses in SLS. Let's have under simple bending and a concrete grade of C30-37 and in the limit state of SLS Q, we know that it's a given that the bending moment caused by permanent loads is 10% higher than the bending moment caused by the mobile loads. The creep coefficient is 2, the depth of the section is 800, the width 250, the concrete cover is 40 millimeters and the stirrup diameter is 10 millimeters. So remember, it's an SLS calculation, so all the parameters are given. The question now is, for this section, what is the maximum allowable bending moment in SLS Q? We assume that the 10% is included in the psi coefficients of the loads. So it means that the effect of the permanent loads and the effect of the mobile loads are not characteristic values, but already values multiplied by the psi factor. Then the effect of the permanent load is then 1.1 the effect of the mobile load. The factor K is then 0.5 to 4, and the modulus of elasticity of concrete is then equal to 16,000 megapascal. And it gives us an alpha coefficient of ES divided by EC equal to 12.5. We know that in SLSQ we expect something in the order of 15. So 12.5 is within this order, so that's fine. We know that the maximum compressive stress in SLSQ is 0.45 FCK. We also know that the maximum allowable stress in the steel is 0.88 FAK. So we have two maximum stresses and we have to check the corresponding moment capacity for those two maximum stresses. Most of the time it's the compressive stress that is the limitation factor. So we start with the compressive stress, it's 13.5 megapascal. The reinforcement, it's 2 diameters 25, it's 982 square millimeters. The effective depth is the total depth minus the stirrup minus the concrete cover and the point of gravity of the reinforcement gives us 737.5 millimeters. The depth of the neutral axis is then 224. The corresponding bending moment, it's pure elastic, so it's quite easy to calculate it. The V is of course equal to the depth of the neutral axis, and the moment of inertia of the cracked section is 4,165 million millimeters to the power 4. The corresponding bending moment is then the E divided by the V multiplied by sigma C max, and it's 251 or 250.8 kilonewton meter. Now we must take care because you cannot round it off to 251 because then the maximum compressive stress in the concrete will be exceeded. So we always have in this kind of calculation round it off downwards. So the maximum capacity is 250 kilonewton meter, but we still have to check the steel stress, and from similar triangles you can check the steel stress is 384, must be smaller than 0.8 times 500, so this is okay. So now you can calculate the maximum bending capacity of a section based on stresses in SLS. See you at next lecture.